Okay, Mr. Holcomb here again with another episode of Math Behind the Module. Okay, so let me go to full screen here and let's take a look. This is lesson 25, a fraction as a percent. Example 1. Here is a diagram. I don't know why there are trailers in the background there, but let's just ignore those. So let's pretend those are not there. They're not going to be counted as a vehicle. Okay. So we have 3 cars and 2 trucks. Sam says 50% of the vehicles are cars. Give 3 different reasons or models that prove or disprove Sam's statement. Models can include tape diagrams, 10 by 10 grids, double number lines, etc., etc., etc. All right, so here's one thing we can do. We can say 50% equals 50 over 100. And that reduces to 1 over 2. Okay? So 50% are cars. And we see 5 vehicles. Okay, 50% of the vehicles are cars. So there are 5 vehicles, so I can say 5 vehicles times our 50 over 100, or 1/2, times 1/2 equals 5 halves, which equals 2 and 1/2. Well, there's obviously more than 2.5 cars. There are 3 cars. So it's not 50% cars. Okay? So there's one reason. Reason number 2. Okay? If I have 5 vehicles, I do a tape diagram. 1, 2, 3, 4, 5. Okay, there's the 5 vehicles. Well, if this has to add up to 100, because percent's 100, this would be 20. This would be 20. This would be 20. This would be 20. And this would be 20. Equaling 100%. 20%, 20%, 20%, 20%, 20%. Well, just looking at this, we have 1, 2, 3 cars and 2 trucks. So now I know the percentage. 60% are cars. Okay. So there's another example proving that's not true. Another way we could do it is we have 1, 2, 3 cars out of 5 vehicles. So we could say, well, let's see, the ratio of cars to the total vehicles is 3 to 5. If I multiply that by 20 over 20, why do we do that? Because we want out of 100, we want 100%. We want 100 in the denominator. 5 times 20 is 100. 20 divided by 20 is 1. 3/5 times 1 is still equivalent to 2 3/5, but now it's 60 over 100, which then shows us another way of saying 60%. So it says, how is the fraction of cars related to the percent? Three-fifths is equivalent, it's right here. 3/5 is equivalent to 60 out of 100, which is 60%. Okay. Use a model to prove that the fraction and the percent are equivalent. Okay. So how about a tape diagram? Or not tape diagram, but a double line diagram. So if I do this, okay, what are we comparing? Cars, or vehicles, I should say, not cars. Cars and trucks, which we will call vehicles. Vehicles and percent. Okay. So we start out at 0%. They don't have any vehicles. One vehicle is 20%. Two vehicles is 40%. Three vehicles is 60%. Four vehicles is 80%. And finally, 5 vehicles is 100%. Okay. We have 3 cars. So 60% of the vehicles are cars. Okay, so now let me erase that to get it out of the way. If you need it, rewind, pause, whatever. What other fractions or decimals are also represent? What other fractions or decimals also represent 60%? Well, remember, if I move the decimal 2 places to the left, that'd be 0.60. 60 out of 100. Okay, and there's all kinds of others. 6 out of 10, 3 out of 5. I can multiply by anything as long as the top and bottom are multiplied by the same thing. All right? All right, page 2. Example 2. A survey was taken that asked participants whether or not they were happy with their job. An overall score was given. 300 were unhappy, while 700 of the participants were happy. 300 were unhappy. 700 were singing the Pharaoh song. All right. Give a part to whole fraction of the company, comparing happy to all of them. Okay, I used red for happy, so I'm going to use red again. So, happy, 700 out of the total 700 plus 300, which is 1,000. As a percent, I would reduce that to 70 out of 100 by dropping one of these zeros here. Okay, dropping one of those zeros there, and that would be 70 over 100, or 70%. Unhappy would be the remainder. 300 out of 1,000. Okay. Canceling these zeros here would give us 30 over 100, which is 30%. Okay, so there you have it. Create a model to justify your answer. Okay. How about another 2-line diagram? Okay. Percent up here. And number of people down here. So if this was 10%, 10% of 1,000 is 100. So we're going to go 200, 300, and so on. Okay, didn't draw my line quite far enough. Let's do this. Make that a line. And then this is 20%, 30%, 40%, 50%, 60%, making sure these line up, 70%, 80%, 90%, and 100%. Right about there. Okay. So, happy was red, 70% of 7, which is 700, and 30% of 1,000, which is 300. And there's our table, our model. Okay. Exercise 1. Renita claims that a score of 80% means that she answered 4 out of 5 of the problems correctly. She drew the following picture to support her claim. Is she correct? Why or why not? Well, we need to know what's going on here, so let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 by 1, 2, 3, 4, 5. That's 5. That's 20. That totals 100 squared. So she's got 100% here. Okay. Now it's hard to see on screen here, but in the students' books, these are shaded. Okay. It's really hard to see on this screen, but this is shaded right here. So how many are shaded? Well, 20, 40, 60, 80 are shaded. Okay, 80%, 4 out of 5. She drew the following picture to support her claim. Is she correct? Yes. Why? Okay, a lot of you don't answer the two-part questions. You say yes and move on to the next problem. There is a why portion here. And you could say 80 over 100 equals 8 out of 10 equals 80%. Anything, something like that. Okay, and 8 out of 10 equals 4 out of 5 if you reduce it. So just showing that explains why. 80 out of 100 is equivalent to 8 out of 10, which is reduced to 4 out of 5, and it's 80%. So yes, 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 it does. She is correct. Okay, how could you change Renita's picture to make it easier for her to see why she is correct or incorrect? Well, we could reduce this. We could get it down to that. And we could make a table and go like this. 1, 2, 3, 4, 5. Made it a little too large. Let's get rid of some of that. Okay, 5 squares. And shade 4 of them. Okay. There's many answers to that question. There's many ways we can do these things. Exercise 2. Use the diagram to answer the following questions. So we have a tape diagram. 20% is 1, 40% is 2, 60% is 3, 80% equals 4, 100% is 5. So whatever they're talking about here, it could be those vehicles again. 5 vehicles, 100% of the vehicles. 80% is what fraction of the whole quantity? 80% is what fraction of the whole quantity. So it's 4/5. Okay? 80 is equivalent to 80 lines up with the 4, and the whole thing is 100% or 5. So it's 4 over 5. Then it says 1/5 is what percent of the whole quantity? Well, this is 0/5, 1/5, 2/5, 3/5, 4/5, 5/5. 1/5 is right here. That is 20%. Okay, percent, not 20, 90. 50% is what fraction of the whole quantity? Well, we don't have a 50%, but it would be right here, smack dab in between these two numbers, so it would be 2 1/2. So 50% is what fraction of the whole quantity? A half. Didn't ask for the value there, it's just a half. Exercise 3. Maria completed 3/4 of her workday. Create a model that represents what percent of the workday Maria has worked. Okay. Well, I could do this. All right. Percent. Portion of day or hours or something like that. So 0 is 0% of her workday. 1 could be, I 5%. Since we're talking about 3/4, we want to go in fives. 50%, 75%, and 100% here. 1, 2, 3, 4. Okay? So Maria completes 3/4 of her workday. 3/4 equals 0.75, which is 75%, or 3 out of the total 4. Either way you want to look at it. Okay? So she completed 75% of her workday. What percent of her workday does she have left? Well, if she's worked 75%, 25% is left, but 75 plus 25 equals 100% means out of 100. How does your model prove that your answer is correct? The model shows that 3/4 is 75% and that 1/4 left is 25%. Okay. Exercise 4. Matthew completed 5/8 of his workday. And what decimal would also be describing the portion of the workday he has finished? 5/8. Well, that just means 5 divided by 8. 8 won't go into 5, but 8 will go into 50 6 times, with the remainder of 2. 8 goes into 20 2 times. 8 times 2 is 16, with the remainder of 4. 8 goes into 40 5 times, even. So it's 0.625. 0.625 would be the decimal. Decimal, 0.625. How can you use the decimal to get the percent of the workday Matthew has completed? Well, going from decimal to percent, we're going to go to the right 2 decimal places. So that would be 62.5%. 5. Complete the conversions from the fraction to decimal percent. Fraction 1/8. Decimal, I'll do my work up here. 8 goes into 10 once, 8, 20. 8 goes into 22 times, that's 16 and 5. Okay? So 1/8 is 12.5%. 0.125 or 12.125 is the decimal. So the percent is 12.5%. Now we're given the decimal 0.35. Well, as a fraction, that would be 35 over 100. 5 will go into 35 7 times. 5 will go into 100 20 times. So the fraction reduced would be 7 over 20. A percent would be 35%. Now we're given the percent. To move it to a decimal, we move the decimal place 2 places. So this is 0.845. That's tenths, hundredths, thousands. That'd be 845 over 1,000. 5 will go into 8 1 time. 5 will go into 34 6 times. 5 will go into 45 9 times. 5 will go into 1,000 200 times. 169 over 200. Okay. Let me see if that reduces. Okay. That 169 over 200 does not reduce, so that's the answer. And now we have a decimal. So to move over to the percent, we have to move the decimal 2 places to the right. That's 32.5%. And 325 tenths, hundredths, thousandths. Again, we're going to do 325 over 1,000. And just to save some time here, I'll show you how to do that on the calculator. 325 divided by 1,000. Enter is 0.325. Now this fancy calculator, if I hit math and enter twice, it'll change it to a fraction and reduce it for me. It is 13 out of 40. Okay, yeah, I highly recommend you be able to do that. Okay, what's the value again? $13 out of 40. 13 out of 40. Okay, so reduce, reduce, reduce. 2 out of 25, if I multiplied that by 4 over 4, I'm going to get 8 out of 100. Okay, that's 8 100ths. That's 0.08. 0.08, which is 8%. Okay. And finally, exercise 6. Choose one of the rows from the conversion table in exercise 5. Use models to prove your answers. Models could include 10 by 10 grid, tape, double number line, etc. So from exercise 5, this here, it says choose one of the rows from the conversion table and use models. All right. Well, I'm going to pick the bottom one right here. And I'm going to go with the original. So I'm going to make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, that's 11. Get rid of this one. There's 10. I want 25 of them. There's 20. 1, 2, 3, 4, 5. And there's 5. There are 25 squares. 2 are shaded. Okay. All right, lesson summary. There you have it. I'm not going to go over all of this. Video's getting kind of lengthy, 22 minutes, so I'm going to stop here. Go do your problem set.